Okay, today we're going to look at finding and using relationships in similar right triangles. Remember to take notes and to upload those with your assignment. In a right triangle, we have some similarities that can happen. And basically, what this theorem lets us know is that if you do have a right triangle and the right angle is, for instance, in this case, the right angle is at C. And CD, which is the line that would come from the right angle down to the opposite side, and it would be perpendicular to the opposite side, and that would be something called the altitude. So we have an altitude going to the hypotenuse. That altitude allows us to know that there's two similar triangles that are similar to the original triangle and to each other. So basically this altitude divides it into two other triangles that's similar to the original one. So we have, for instance, over here, over here you have the three similarities that would end up happening. And you have triangle ABC, which is your big triangle, and it's going to be similar to one of the smaller triangles that it forms, which is ADC. And then it's also going to be similar to the medium-sized triangle that it creates, which is CDB. And then those two smaller triangles are also congruent to one another. Sorry, not congruent, similar to one another as well. Okay, so it wants us here to write the similarity statement based on the triangle that we have. And there will end up being three triangles. Okay, so let's look at the three different triangles that would end up happening. First, you have your bigger triangle. Sorry, I needed a pen, not a highlighter. First, you have your big triangle, which in this case would be Z, Y, X, and Y is where our 90-degree angle is. Okay, then we have another triangle, which is WYZ, and that would be made with the altitude and then formed that way. Okay, and your 90-degree angle would be down here where W is. Okay, so I'm going to try to orient it the same way. Okay, W is where my 90-degree angle would be. And then Y would be up here, and Z would be here, obviously, because Z and Z. Okay. All right, then we have another triangle formed over here, which is YWX, and W is obviously where your 90-degree angle is. So we're going to make a smaller triangle. My 90-degree angle is here, which is W, and then my Y I'm going to put here, and X is going to go up here because I'm relating it back to the original triangle, so there's my X up at the top. Okay, so to write out my similarity statement, these three triangles are going to be similar to one another. So my first triangle, I've got XYZ. It's going to be similar to triangle YWZ, and that's going to be similar to XWZ. Sorry, not Z, Y. And these should have triangles in front of them. I apologize. Okay, Another thing that we need to look at is finding the geometric mean. Proportions in which the means are equal occur frequently in geometry. And basically it comes out to be something called the geometric mean. And it's going to happen anytime that you have a proportion set up in which these two are equal to one another. And what's going to happen is you end up with the answer being the square root of A times B. Okay, so anytime that happens, that's how you find your geometric mean. So if you have this equal to this, then to find your answer, you're going to do the square root of A times B. Okay, so let's look at what the geometric mean would be for 6 and 15. So to do the geometric mean, I'm going to multiply the two together and take the square root of it. Okay, so 6 times 15 is going to give me 90, so I'm looking at the square root of 90. Notice none of these are the square root of 90. So what we're going to do is we're going to simplify the radical like I taught you how to do yesterday. So that breaks down to 9 and 10. 9 breaks into 3 and 3, and 10 into 2 and 5. So you have a 2, 2 3s, and a 5. So you have one set of 3s. So you have a 3 on the outside, and then you have a 2 and a 5 left on the inside. So it should be 3 radical 10. So B would be your answer. Now another thing you can do is you can take the square root of 90 and get a decimal. And let me find out what that would actually be. So the square root of 90 is 9.48. And you can go through, and obviously 90 is not going to be it. But if you do 3 times the square root of 10, well, the square root of 10 is 3.16. And if I times that by 3, I get the 9.48. So that lets you know that it's the middle term, or the middle answer there. Okay, what's the geometric mean of 4 and 18? So that would be represented by, if you had 4 over x equals x over 18. To find that out, we can do 4 times 18 and then take the square root of it. So 4 times 18 is 72. And then I'm going to do a factor tree with 72. So that would be, I'm going to use 6 and 12. 6 goes to 2 and 3. 2 goes to 2 and 6. And 6 goes to 2 and 3 as well. So I have 3 2s and 2 3s. So I have one set of 2s, one set of 3s. So 2 times 3 is on the outside and 2 is left on the inside. So 6 radical 2 would be your geometric mean. Alright, so when I have those right triangles that we were kind of looking at there at the beginning when we was breaking it into 3 different triangles, there's 2 different corollaries, which is basically just kind of like an extension to that theorem that we were looking at. And this is kind of letting us know how we can set up so that we can solve for various lengths that we may be missing. So what this one tells us is that the length of the altitude, so the length of CD, which would be my altitude, to the hypotenuse of the right triangle, is the geometric mean of the lengths of the segments of the hypotenuse. So it's the mean of this segment and this segment. Okay. So you can set it up as AD, which is this segment here, over the altitude is equal to the segment CD over the other segment of the hypotenuse, which is DB. So they've given us like a little example here. You have your small segment over your altitude over your larger segment. Okay, so again, you'll see that here. And I would have probably, instead of putting short leg, long leg, I would have probably put altitude. Okay. And then the next one, there's two different ones that we can use. The next one here basically tells us that the altitude to the hypotenuse of the right triangle separates the hypotenuse so that the length of each leg of the triangle is the geometric mean of the length of the hypotenuse and the length of the segment of the hypotenuse adjacent to the leg. So what that means is AC, which is here, is going to be the geometric mean of AB, which is the entire hypotenuse, and the AD, which is the smaller segment of the hypotenuse. Okay, so you basically have your hypotenuse. So to set this one up, you have your hypotenuse here, your whole hypotenuse. This is your leg that's adjacent to the hypotenuse. And this one here is the segment of the hypotenuse adjacent to the leg. Alright, so let's look at how to set these up. And if I was you, when I was setting these up, I would just kind of use this little diagram here to help you set it up. But it wants to know what are the values of X and Y. So notice in this one that they are giving us the altitude. They're giving us that middle segment there, okay? So the easiest way to set that one up is going to be actually to use this, corollary 1. So with that being said, we're going to do S1, which is this piece of the triangle, which in this case would be 4, over A, which is your altitude, so in this case is Y, is equal to Y over S2, which is that other piece of the altitude, of the hypotenuse, which would be 12. Okay, so 4 times 12, and take the square root of that. Well, sorry, I just dropped my phone. So 4 times 12 is 48. And I'm going to do a factor tree with 48. Now, if you leave it as square root 48 or give me the decimal for it, I'll still count it. That's fine. But 48 is, I can break that into 8 and 6. 8 is 2 and 4, and that would be 2 and 2. And 6 is 2 and 3, so I have actually 4 2s and a 3. So I have 2 sets of 2s and then a 3. So I have 4 radical 3 as my answer for Y. Okay, now I still have to figure out what X would be. Oh, well, I didn't want to do that. I'll have to redraw that. Sorry. I didn't mean to take away the problem. Okay, so that was Y. X is this leg adjacent to the hypotenuse, and this is 4 and 12. So if I'm dealing with trying to find a leg, then I want to use corollary 2, okay? So if that's the case, then I'm not looking for the hypotenuse, I'm looking for a leg. So first I need the full hypotenuse, so that would be 4 plus 12. That's where I'm getting this. And then leg 1 would be x, and then equal to leg 1 again, which is x, over S1, which they've showed me here is the smaller part of the hypotenuse, which would be 4. Okay, so full hypotenuse over leg equals leg over small part of the hypotenuse. Okay, so 4 plus 12, it's going to give me 16 over x equals x over 4. I'm going to do 16 times 4, because to find x, I would do the square root of 16 times 4, which is the square root of 64, and that's actually a perfect square, so the square root of 64 is 8. Okay, so you do have some book work to complete today. Please make sure that you submit a picture of your work and your notes on Google Classroom. If you need help, please just let me know and we can set up a Google Meet. My email is provided there if you need to reach me, or you can always just call me on Google Classroom or use the Remind app. Hope you guys have a good day.